visit a website, the request does not go straight to one server. Instead, a load balancer acts as an intermediary. It examines the traffic and intelligently decides where to send each request. So now let's move on to dynamic load balancing algorithm. These algorithms are more advanced because they make decisions in real time based on current system condition. All the traffic is being directed to a single server, and due to this, what is happening that overload is happening on server side. Whether it's scrolling through pictures on Instagram or listening to music on Spotify, users basically expect a fast and smooth experience no matter how many people are online. Hey everyone, welcome to Prep Train YouTube channel. I am Sahib Kumar and I am super excited to have you here today. Whether you are a student, a budding tech enthusiast, or someone just looking to level up your backend knowledge, you have come to the right place. At Prep Train, we are all about learning, growing, and giving you practical tips to help you ace the tech world. So let's talk about today's topic, load balancing. It might sound a little technical, but trust me, it's one of those concepts that you are going to find incredibly useful even if you are diving into the world of web application or backend engineering. Imagine being able to understand how Netflix, Instagram, and Spotify keeps everything running smoothly even with millions of users online at the same time. That is what load balancing helps with, and today we are going to break it down for you step by step. Now, if you are here, make sure that you hit that subscribe button and turn on the notification bell so that you don't miss any of our awesome content that we have got lined up for you. And also, don't forget to join our Prep10 Telegram community. It's a great place to stay updated on the latest job and internship opportunities, as well as to connect with others who are passionate about learning and growing in tech field. Alright, let me just bring my deck and then we will continue diving deeper into load balancing and how it keeps basically the internet running smoothly. Stay tuned. Alright, so let's kick things off by addressing a fundamental concept that what is load balancing. So imagine that a popular platforms like Instagram or Netflix. So these services basically handle millions of users accessing their platform simultaneously without any noticeable slowdowns or crashes. So how do they manage this? The answer basically lies in load balancing. At its core, basically load balancing is about distributing the traffic, whether it's web request, data transfer, or computations across multiple servers. Think of it as a system designed to share the workload efficiently. So no single server bears the entire burden, which means servers are less likely to become overloaded and crash under pressure. So when you visit a website, the request does not go straight to one server. Instead, a load balancer acts as an intermediary. It examines the traffic and intelligently decides where to send each request. So ensuring that even distribution of workload is there across all the servers. This not only helps server perform optimally, but also enhances the end user experience with faster response time and reliable success. The absence of load balancing would lead to server overloads, causing significant downtime for website and app, and this can result in a frustrated user and potentially major financial loss for businesses. The diagram on this slide basically shows that how basically a load balancer operates. So it basically takes incoming traffic that comes and coming from basically multiple users, and it assesses the situation and then directly it directs each request to an appropriate server in the network. So these servers then can connect with the database behind the scene, and likewise the entire operation is done. So as we dive deeper, keep this foundational concept in mind that load balancing is basically critical for ensuring the stability and reliability for modern digital platforms. Now that we have understand what load balancing is, let's move on to the next slide where we will explore how a load balancer basically operates in real world scenarios. Now that we have established what load balancing is, let's take a closer look at how a load balancer works in action. So picture a load balancer as a traffic cop basically managing flow of web requests. So it stands between the users and the servers, ensuring that requests are efficiently routed. When you or anyone else access a website, the load balancer steps in to assess the situation. It then determines which server is best equipped to handle the request based on various factors such as current server workload and availability. So the first key function of a load balancer is to act like a traffic cop. It monitors all incoming requests and prevents chaos by directing each request to the right server. This process basically ensures that traffic is managed smoothly, avoiding congestion on any single server. Next, the load balancer uses intelligent routing to send traffic to the least busy server. For example, if one server is processing a high number of requests while another one is relatively free, the load balancer will basically route your request to the less burdened server. This ensures optimal resource utilization and keep things running efficiently. Lastly, a crucial benefit of load balancer is its ability to ensure fast response time. By spreading the load evenly and avoiding overloading any server, it helps maintain the speed and performance of website or application. Users don't experience delays and businesses can provide a seamless experience even during peak traffic times. Let's move to the next slide and discuss problems that can happen without a load balancer. So before diving into how load balancing works, let's first understand the problem that arises without it. So first of all, single point of failure. So imagine that all of your traffic is directed to a single server. If that server basically goes down due to a technical issue or overload, so your entire application can become inaccessible. This is nightmare for service providers because it can directly impact user satisfaction. Secondly, we can say overloaded server. So as businesses grow, the number of users increases. So a single server has limit to the number of requests it can handle at once. So beyond that limit, the server becomes overwhelmed, leading to slower response time or complete failure to serve a request. One more problem that we have is limited scalability. So without a load balancer, adding more server to handle the growing traffic isn't straightforward. The single server act as a bottleneck and new servers cannot effectively share the load without manual reconfiguration or significant changes to the system. Let's take this example. So on this slide, the graphic that I have put on, so on the top, all the traffic is being directed to a single server, and due to this, what is happening that overload is happening on server side, while on the bottom a load balancer is basically efficiently distributing all the traffic to different multiple servers and solving this overloading problem. Now that we understand the concept through this example, we are ready to dive into specific strategy used in load balancing. Let's explore this strategy on the next slide. All right, so this one looks cool. So let's start by understanding static load balancing algorithm. So these are simplest form of load balancing because they rely on predetermined rules to allocate tasks. So by definition, if you say that static load balancing does not consider real-time changes in the system, once tasks are assigned to the server, the system does not adapt to traffic fluctuation or changes in system performance. We have round robin. So the round robin algorithms basically distributes incoming requests across server in a sequential and cyclic manner. So for example, if there are three servers, the first request goes to server 1, the second to server 2, the third to server 3, and then it repeats. So this is simple and works well when all servers have basically equal capacity. We also have something called as weighted round robin. So in this variation, each server is assigned a weight based on its processing power or capacity. The servers with higher weights receive a proportionally greater number of requests. For instance, if server 1 has basically a weight of 3 and server 2 has a weight of 1, server 1 will handle 3 times as many requests as server 2. We also have source IP hash. So this algorithm basically uses the client IP address as input for hashing function. So this output basically determines which server handles the request. So it ensures that client requests are constantly directed to the same server, which can be useful for maintaining session data. These technologies are straightforward but may not basically handle dynamic changes effectively, which leads to dynamic load balancing. Next, let's explore dynamic load balancing algorithms. So now let's move on to dynamic load balancing algorithm. These algorithms are more advanced because they make decisions in real time based on current system condition. If we talk about its definition, basically dynamic load balancing monitors the system and adjusts the distribution of traffic according to factor like server load, response time, or network condition. So this adaptability makes it ideal for environment with fluctuating traffic and server performance. Let's discuss two more algorithms. The first one is least connection method. So this method basically checks how many active connections each server currently has and then directs new traffic to the server with the fewest connections. For example, if server 1 has 5 active connections, server 2 has 3 and server 3 has 8, the next request will basically go to server 2. This ensures that no single server is overwhelmed when others are underutilized. We also have least response time method. So here the algorithm basically directs the traffic to the server that responds to the fastest. So it continuously monitors response time, which include both processing and network latency. And for instance, let's say if server 1 has a response time of 20 millisecond and server 2 has a response time of 10 millisecond, the next request will basically go to server 2. This approach minimizes the delay for users, and dynamic algorithms basically are essential for modern systems that need to handle unpredictable traffic patterns and maintain optimal performance. Let's now discuss how does the load balancer basically verify that each server is still up and running smoothly. Now let's dive into another essential feature of load balancing, health checks. So just as you would check if a car is running properly before taking it for a long trip, load balancers basically perform regular health checks to ensure that the servers are functioning properly and can handle incoming requests. So a health check is basically a process where the load balancer regularly pings each server to verify that it is still up and running smoothly. So if a server does not respond within a specified time, basically the load balancer knows that it is down or unavailable. And then starts skipping routing traffic basically to that server. The idea behind health check is simple. You want to make sure that only healthy servers handle traffic. If a server is down or unable to process requests, it is best to avoid it and ensure that user experience basically remains uninterrupted. So this helps prevent issues like users landing on error pages or waiting forever for a page to load because the server they were directed to is unresponsive. By performing continuous health check, load balancers can quickly identify when a server is not performing as expected, and they can then redirect the traffic to other healthy servers, keeping the system running smoothly. Once the problematic server basically comes back online and passes the health check, it is added back to the rotation to handle incoming request. In the diagram that you are seeing here on this slide, basically what is happening that you can see how the load balancer pings the server to check their status, and if any of the server are down, let's say this one. So what will happen that the load balancer detects this and avoids sending requests to them, and it ensures that users always get a response from a functioning server. With health checks in place, a website or app is far less likely to experience significant downtime, and users are less likely to encounter errors or delays. So this feature is a vital part of maintaining the reliability part of large scale systems. Next, let's take a look at some real world example of how load balancing is basically applied in practice to help some of the world's most popular platform. Let's move to the next slide. Now that we have covered the technical aspect of load balancing, let's look at some real world examples to see how this technology is used by major companies to ensure smooth user experience. For instance, Netflix relies heavily on load balancing to manage massive traffic spike. Think about what would happen when a new season of a popular show like, let's say, Stranger Things or Lucifer is just released. Millions of users around the world simultaneously access Netflix to stream their favorite episode, and without proper load balancing, this could easily overwhelm Netflix server and cause them to crash. Load balancing basically ensures that these spikes in traffic are distributed evenly across Netflix infrastructure so users can stream seamlessly without interruption. Similarly, Instagram and Spotify also depend on load balancing to handle millions of simultaneous users, whether it's scrolling through pictures on Instagram or listening to music on Spotify. Users basically expect a fast and smooth experience no matter how many people are online. Load balancing basically makes this possible by intelligently routing traffic and ensuring that no server gets overwhelmed even during peak usage time. These are just a few examples, but the truth is that load balancing is everywhere in large scale web applications. And every time that you open an app or visit a website, chances are there that a load balancer behind the scene is ensuring that everything runs smoothly no matter how much traffic is hitting the system. Now that we have seen how these giants uses basically load balancing, let's quickly recap what we have learned today and highlight the key takeaways. All right. So before we finish up, let's quickly recap everything that we have basically covered today to reinforce the key points. First, the load balancers are crucial because they distribute traffic across multiple servers and preventing any one server from becoming overwhelmed. This ensures that the website and apps can handle large volumes of traffic and remain responsive even during peak times. Next, we discussed two common load balancing strategy, round robin, where traffic is distributed evenly in a cyclic fashion, making it simple but effective method. We also discussed about least connections, which is more intelligent approach that sends requests to the server with least amount of current traffic, ensuring basically that faster responsive time and better resource utilization is there. We also covered health checks, a critical feature of load balancing, and these checks ensure that only healthy servers are handling requests. So if a server goes down, the load balancer basically automatically skips it, and it prevents users from experiencing issues like slow loading or downtime. Finally, we saw how companies like Netflix, Instagram, and Spotify basically uses load balancing to ensure that smooth user experience for millions of people is present. Load balancing is basically a fundamental part of backend engineering, and it allows this platform to scale and perform well even under heavy traffic loads. With that, I hope now you have a better understanding of what load balancing is and why is it essential in modern web application. It is a powerful tool that helps ensure reliability, speed, and smooth user interactions. Thank you so much for sticking with me until the end of this video. I hope now you have a solid understanding of load balancing and why it is such a crucial part of backend engineering. We covered everything from basics to real world applications, and now you know that how companies like Netflix, Instagram, and Spotify basically keep things running smoothly with millions of users online at once. If you found this video helpful, don't forget to give it a thumbs up, and it really helps our channel grow and reach more people who wants to learn with us. Also, make sure to subscribe to Print Train and hit the notification bell so that you never miss any new video. We have got plenty more coming your way, especially on topics like backend engineering, coding, and tech industry tips. So if you are looking for more resources and job updates, be sure to join our Prep10 Telegram community. It's a great place to stay connected and get latest job openings and network with others in the tech field. Thanks again for watching, and I'm excited to share more knowledge with you in our future videos. Stay tuned for more, and remember, we are always here to help you level up with your skills and your career. Until next time, take care of everything and keep learning.